Mars quakes. NASA detects subsurface activity on Mars' far side, unlike any other event observed. From what they say, NASA's InSight lander recorded its two largest seismic tremors on Mars, and for the first time, these quakes originated on the opposite side of the planet, allowing the team to probe deeper into the red planet's internal structure than ever before. The pair of Mars quakes, the Martian equivalent of earthquakes, were determined to have magnitude of 4.2 and 4.1. Both are 5 times stronger than the previous recorded tremors detected by NASA on Mars. They're also the first Mars quakes that the InSight lander seismometer has detected, originating from the opposite side of the planet to the lander. And according to seismologist Dr. Anna Horleston of University of Bristol of the UK and her colleagues, the findings could help scientists better understand Mars' interior structure, in particular the nature of the planet's core mantle boundary. The larger of the two Mars quakes, dubbed S0976A, struck August 25th of last year and appears to have originated in the Valles Marianas, a 2,500-mile-long canyon system that is 4 times deeper than the Grand Canyon here on our Earth. The presence of criss-cutting fault lines and landslide debris in the area, previously seen in satellite images of the canyon, suggests that the Valles Marianas would be geologically active, but this is the first time scientists have direct evidence of seismicity. The researchers said they were able to detect the so-called PP and SS waves from magnitude 4.2 event, and that is respectively compressional and shear waves that have been reflected at least off the Martian surface en route to the InSight seismometer. Dr. Horleston said the S0976A looks like many of the events we have located to Cerberus Fosse, an area of extensive faulting that have depths modeled to be around 50 kilometers, 31 miles deep or more, and it's likely that this event has similar deep source mechanism. The magnitude 4.1 Mars quake, meanwhile, was recorded 24 days later on 18th of September and has the distinction of being the longest recorded on Mars, lasting for 94 minutes. Analysis of the data from the InSight reveals that alongside PP and SS waves, the lander also picked up so-called Diff Waves that travel along Mars' core mantle boundary for part of their journey from the quake focus to the seismometer. This is the first time that Diff Waves have been detected by the InSight lander. The researcher said that, like the S0976A Mars quake, this second quake, dubbed S1000A, has its origins on the far side of the planet, although they have been unable to pin down the source location. Unlike the low-frequency S0976A, the waves from S1000A had very broad frequency spectrum. The second quake, Dr. Horson said, is a clear outlier in our catalog and will be key to our further understanding of Martian seismology. She said that the S1000A Mars quake has a frequency spectrum much more like a family of events that we observed that have been modeled as shallow crustal quakes, so this event may have occurred near the surface, she says. Now, the respective location of the InSight lander and the origin points of the two Mars quakes means that the seismometer readings were taken in what seismologists call the core shadow zone. This is the relative region on Mars' surface where P and S waves from the given quake cannot directly travel to a seismometer because the waves are either refracted or blocked by the planet's liquid iron core. Paper author and seismologist Dr. Savas Salin of ETH Zurich said recording events within the core shadow zone is a real stepping stone for understanding of Mars. Prior to these two events, the majority of the seismicity was about 40 degrees distance of the InSight. Being within the core shadow, the energy traverses parts of Mars we've never been able to seismologically sample before. Now, this, in terms, the team explains, makes the two new far-side quakes special in our current record of Mars seismic activity. Dr. Horrison concludes that not only are the largest and most distant quakes events by a considerable margin, but the S1000A has a spectrum and duration unlike any other event previously observed. We said 94 minutes. They truly are remarkable events in the Martian seismic catalog. The full findings of the study were published in the journal The Seismic Record. And this is on Express UK by Ian Randall. Now, you can imagine if astronauts were on there and having a quake lasting an hour and a half, what it would be. Please leave your comments about this, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.